अब आते हैं हमारे कॉम्बिनेशन ऑफ सर्कल्स पे। अगर हम दो सर्कल्स की बात करें जिनमें से पहला सर्कल है सपोज एक्स स्क्वायर प्लस वाई स्क्वायर प्लस 2g1x प्लस 2f1y प्लस c1 इक्वल 0, और दूसरा सर्कल है एक्स स्क्वायर प्लस वाई स्क्वायर प्लस 2g2x प्लस 2f2y प्लस c2 इक्वल्स टू 0। अब पहले सर्कल के लिए जो सेंटर आएगा वो आएगा आपका -g1 माइनस f1 पे, और उसका जो रेडियस है वो हो जाएगा आपका अंडर रूट ऑफ g1 स्क्वायर प्लस f1 स्क्वायर माइनस c, और जो दूसरे सर्कल का सेंटर होगा वो होगा -g2 माइनस f2 पर, और इसका जो रेडियस आएगा वो आएगा अंडर रूट ऑफ g2 स्क्वायर प्लस f2 स्क्वायर माइनस c2। पहले वाले में c1 है, दूसरे वाले में c2 है। अब सपोज इसका सेंटर है कैपिटल C1 और इसका सेंटर है कैपिटल C2, तो दोनों सेंटर्स के बीच में डिस्टेंस निकाल सकते हैं डिस्टेंस फॉर्मूला यूज करके। तो ये जो C1 C2 है वो हो जाएगा अंडर रूट ऑफ g1 माइनस g2 स्क्वायर प्लस f1 माइनस f2 स्क्वायर। अब ये जो दोनों सर्कल्स हैं इनकी रिलेटिव पोजीशंस 5 तरीके से हो सकती है। या तो सिचुएशन ऐसे हो सकता है कि दोनों सर्कल्स एक दूसरे को इंटरसेक्ट नहीं करता है, या फिर दूसरा कंडीशन जहां पे दोनों सर्कल्स एक दूसरे को एक्सटर्नली टच करते हैं। तीसरा केस जहां पे दोनों सर्कल एक दूसरे को 2 पॉइंट्स पे इंटरसेक्ट करते हैं। चौथा केस जहां पे ये दोनों एक दूसरे को इंटरनली टच करते हैं, और एक पांचवा केस जहां पे एक सर्कल दूसरे सर्कल के अंदर कंटेंट है। तो ये हमारे 5 कॉन्फ़िगरेशंस बनते हैं दो सर्कल्स को लेके। अब यहां पे इनके सेंटर्स हैं C1 C2। तो पहले कंडीशन में 2 circles they do not intersect। इसके लिए कंडीशन ये है कि C1 C2 बड़ा होना चाहिए R1 प्लस R2 से। तो अगर सेंटर्स के बीच का डिस्टेंस R1 प्लस R2 से बड़ा है तो ये दोनों सर्कल एक दूसरे को इंटरसेक्ट नहीं करेंगे। दूसरा कंडीशन है जबकि दोनों सर्कल्स एक दूसरे को एक्सटर्नली टच करते हैं, तो सर्कल्स टच एक्सटर्नली। तो अगर सर्कल्स एक दूसरे को एक्सटर्नली टच करते हैं तो वो केस में इनके सेंटर्स के बीच का डिस्टेंस C1 C2 ये बराबर आता है R1 प्लस R2 के। तो ये हमारे लिए इंपॉर्टेंट केस है जहां पे हमको कंडीशन देगा दो सर्कल्स एक दूसरे को एक्सटर्नली टच करते हैं। तो यहाँ पे ये जो डिस्टेंस है ये डिस्टेंस बराबर होना चाहिए R1 प्लस R2 के। अभी तीसरे केस को थोड़ी देर में डिस्कस करेंगे, पहले डिस्कस करते हैं ये चौथा केस। तो यहां पे जो दोनों सर्कल्स हैं ये एक दूसरे को टच करते हैं इंटरनली। तो सर्कल्स टच इंटरनली। तो अगर दो सर्कल्स एक दूसरे को इंटरनली टच करेंगे तो यहां पे ये है C1 और ये है C2। तो ये केस में C1 C2 बराबर होना चाहिए मॉड ऑफ R2 माइनस R1, यानी कि जो भी इसमें से बड़ा पॉजिटिव वैल्यू है मॉडुलस वैल्यू ऑफ डिफरेंस ऑफ देयर रेडियस। तो ये केस भी हमारे लिए इंपॉर्टेंट है जहां पे सर्कल एक दूसरे को इंटरनली टच करते हैं। अब आते हैं ये तीसरे केस पे। अब ये जो तीसरा केस है ये तीसरा केस बेसिकली ये दोनों के बीच का केस है। तो यानी इस केस में सर्कल्स इंटरसेक्ट एट 2 पॉइंट्स। यहां पे C1 C2 जो है वो बड़ा होना चाहिए मॉड ऑफ R2 माइनस R1 के, लेकिन छोटा होना चाहिए R1 प्लस R2 से। तो दो सर्कल्स एक दूसरे को दो पॉइंट्स में इंटरसेक्ट तब करेंगे जब उनके सेंटर्स के बीच का डिस्टेंस R1 प्लस R2 से छोटा है लेकिन R1 माइनस R2 से बड़ा है। और ये पांचवा केस जहां पे वन सर्कल इज कंटेन्ड इन अनदर, तो जहां पे एक सर्कल दूसरे सर्कल के अंदर कंटेन्ड है। तो इसके लिए कंडीशन ये है कि आपका जो C1 C2 है ये छोटा होगा मॉड ऑफ R2 माइनस R1 से। तो ये है आपके 5 केसेस जहां पे दो सर्कल्स एक दूसरे के साथ कॉन्फ़िगरेशन बना सकते हैं। अब यहां पे अगर नंबर ऑफ कॉमन टेंजेंट्स की बात करें तो ये केस में हमारे पास दो इनडायरेक्ट कॉमन टेंजेंट होंगे और दो डायरेक्ट कॉमन टेंजेंट्स होंगे। तो यहां पे नंबर ऑफ कॉमन टेंजेंट्स जो आएगा, नंबर ऑफ वो आएगा आपका 4। अब दूसरे केस में यहां पे दो डायरेक्ट कॉमन टेंजेंट होंगे और एक कॉमन टेंजेंट होगा आपके पॉइंट ऑफ कांटेक्ट पे। तो यहां पे नंबर ऑफ कॉमन टेंजेंट्स जो होंगे वो होंगे 3। अब तीसरे केस में जहां के दोनों सर्कल एक दूसरे को इंटरसेक्ट करते हैं तो वहां पे हमारे पास सिर्फ दो डायरेक्ट कॉमन टेंजेंट्स होंगे। तो ये केस में नंबर ऑफ कॉमन टेंजेंट्स होंगे आपके 2। अगर सर्कल्स एक दूसरे को इंटरनली टच करते हैं तो सिर्फ एक ही टेंजेंट आएगा और वो टेंजेंट आएगा इनके पॉइंट ऑफ कांटेक्ट पे। तो इस केस में नंबर ऑफ कॉमन टेंजेंट जो है वो 1 होंगे। नंबर ऑफ कॉमन टेंजेंट्स 1। और जब एक सर्कल दूसरे के अंदर कंप्लीटली लाई करता है तो वो केस में कोई भी टेंजेंट नहीं आएगा। तो वो केस में नंबर ऑफ कॉमन टेंजेंट्स आपका सिंपली 0 आएगा। तो ये है आपके 5 केसेस और ये पांचों ही केसेस में नंबर ऑफ कॉमन टेंजेंट्स अलग अलग आएगा। अब ये पांचों केसेस को एक बार डिटेल में देख लेते हैं। तो पहला केस है हमारे पास जहां पे सर्कल्स एक दूसरे को इंटरसेक्ट नहीं करते। तो सर्कल्स डू नॉट इंटरसेक्ट ईच अदर। और ये दो कंडीशंस में होता है जब या तो एक सर्कल कंप्लीटली दूसरे के अंदर है या दोनों अलग अलग हैं। तो यहां पे हम ये केस डिस्कस कर रहे हैं कि जहां पे दोनों सर्कल्स एक दूसरे से अलग अलग हैं, यानी कि बाहर लाई करते हैं। और ये है उनके सेंटर्स को ज्वाइन करने वाली लाइन। तो ये है C1 और ये है आपका C2। अब पहले वाले सर्कल का रेडियस है R1 और दूसरे वाले सर्कल का रेडियस है R2। तो यहां पे हमारे पास दो इनडायरेक्ट कॉमन टेंजेंट्स होंगे। तो अगर इनडायरेक्ट कॉमन टेंजेंट्स ड्रॉ करते हैं तो ये ऐसे आएंगे। और सपोज ये इनडायरेक्ट कॉमन टेंजेंट्स इंटरसेक्ट करते हैं इस पॉइंट P पर। तो अगर यहां से ये परपेंडिकुलर ड्रॉप करें तो ये जो दोनों ट्रायंगल्स हैं PC1A और PC2B, ये दोनों ट्रायंगल्स सिमिलर ट्रायंगल्स होंगे। और अगर ये ट्रायंगल सिमिलर है तो हम लिख सकते हैं PC1 अपॉन PC2 ये बराबर होगा आपके R1 अपॉन R2 के। तो इसका मतलब ये पॉइंट P डिवाइड करता है C1 C2 को इंटरनली इन द रेशियो R1:R2। तो बेसिकली अगर आपको पॉइंट ऑफ इंटरसेक्शन ऑफ इनडायरेक्ट कॉमन टेंजेंट निकालना है तो उसके लिए आपको सिर्फ ये करना रहेगा कि आपको दो सेंटर्स गिवन है C1 C2, ये है -G1 -F1 और ये है -G2 -F2। तो ये जो पॉइंट P है ये इनको R1:R2 रेशियो में इंटरनली डिवाइड करेगा। अब इंटरनल डिवीजन का फॉर्मूला यूज करके हम यहां पे ये पॉइंट P निकाल सकते हैं। तो इसमें पहला सवाल बनता है ये पॉइंट का कोऑर्डिनेट निकालने के लिए, और इसमें जो दूसरा सवाल बनता है वो बनता है इक्वेशन ऑफ टेंजेंट निकालने के लिए। तो ये जो इक्वेशन ऑफ टेंजेंट्स है इसको हम दो तरीके से निकाल सकते हैं। अब पॉइंट आ गया हमारे पास, तो कोई भी एक सर्कल लेके पेयर ऑफ टेंजेंट्स का इक्वेशन निकाल सकते हैं। तो पहला तरीका है पेयर ऑफ टेंजेंट्स का फॉर्मूला यूज करके, और हमको पता है पेयर ऑफ टेंजेंट्स होता है S1 इक्वल्स टी स्क्वायर। तो हम यहां से ये पेयर ऑफ टेंजेंट्स का इक्वेशन लिख सकते हैं S1 इक्वल्स टी स्क्वायर। अब जनरली जब ये क्वेश्चन पूछा जाता है तो हमसे एक्सपेक्टेड है कि हम दोनों लाइंस की अलग अलग इक्वेशन निकालें। तो यहां पे तरीका ये है कि हम इंटरनल डिवीजन से ये पॉइंट P निकाल लेते हैं। सपोज ये पॉइंट P है x1 y1। अब लाइन का इक्वेशन मान लेते हैं y माइनस y1 इक्वल्स m x माइनस x1। तो यहां से ये आपका टेंजेंट का इक्वेशन आ गया। अब ये टेंजेंट के इक्वेशन में हमको m का वैल्यू निकालना है, तो m का वैल्यू निकालने के लिए हम कंडीशन ऑफ टेंजेंसी यूज करेंगे कि सेंटर से उसका जो परपेंडिकुलर डिस्टेंस है वो रेडियस के बराबर होना चाहिए। आप इसके लिए चाहे सर्कल 1 यूज कर लो, चाहे आप सर्कल 2 यूज कर लो। तो सर्कल 1 के लिए सेंटर दिया है -g1 माइनस f1, इसका रेडियस दिया है, तो सेंटर से परपेंडिकुलर डिस्टेंस को रेडियस के बराबर करेंगे। तो यहां से आपको m के दो वैल्यूज मिल जाएंगे जिससे आप दोनों टेंजेंट्स लिख सकते हैं। अब जैसे कि हमको पता है इसमें दो डायरेक्ट कॉमन टेंजेंट्स भी बनेंगे। तो जैसे दो सर्कल्स हैं हमारे पास, इसका सेंटर C1, इसका सेंटर C2, और ये भी इंटरसेक्ट करेंगे किसी एक पॉइंट Q पर। तो यहां पे ये रेडियस है R2 और ये रेडियस है R1। और यहां पे फिर से अगर ये पॉइंट्स C और D हैं तो ये दोनों ट्राइंगल सिमिलर होंगे। तो इसका मतलब ये जो पॉइंट Q है वो डिवाइड करता है C1 C2 को R1:R2 रेशियो में एक्सटर्नली। तो यहां पे ये पॉइंट Q निकालने के लिए हम एक्सटर्नल डिवीजन यूज करेंगे। तो इनडायरेक्ट कॉमन टेंजेंट C1 C2 को R1:R2 रेशियो में इंटरनली इंटरसेक्ट करता है, और डायरेक्ट कॉमन टेंजेंट्स C1 C2 को R1:R2 रेशियो में एक्सटर्नली डिवाइड करता है। तो यहां केस में भी हमारे पास दोनों सेंटर्स हैं C1 C2, और ये है -g1 माइनस f1, और ये है -g2 माइनस f2। और ये पॉइंट Q निकालने के लिए हम R1:R2 रेशियो लेके एक्सटर्नल डिवीजन फॉर्मूला यूज करेंगे। तो वहां से हमको ये पॉइंट Q मिल जाएगा। अब इसमें भी दूसरा सवाल वही बनता है, इसके टेंजेंट्स का इक्वेशन निकालना। तो पॉइंट Q हमारे पास है सपोज x1 y1। तो यहां से हम वापस से या तो पेयर ऑफ टेंजेंट्स यूज कर सकते हैं S1 इक्वल्स टू टी स्क्वायर किसी भी एक सर्कल को लेके, या फिर वापस से ये पॉइंट यूज करके एक लाइन का इक्वेशन लिख सकते हैं y माइनस y1 इक्वल्स m x माइनस x1। और ये m का वैल्यू निकालने के लिए हम कंडीशन ऑफ टेंजेंसी यूज करेंगे कि सेंटर से उसका जो डिस्टेंस है वो उसके रेडियस के बराबर आना चाहिए। तो वहां से आपको m के वापस दो वैल्यूज मिल जाएंगे। तो या तो क्वेश्चन में आपको पॉइंट पूछेगा जहां पे डायरेक्ट या इनडायरेक्ट कॉमन टेंजेंट्स इंटरसेक्ट करते हैं, या फिर आपको वो टेंजेंट्स के इक्वेशन पूछेगा। अब इसमें जो तीसरा चीज पूछते हैं वो इसका लेंथ ऑफ टेंजेंट। Now the question is, if d is the distance between centers of two circles whose radius are r1 and r2, the length of direct common tangent is given by under root d square minus r1 minus r2 whole square, and length of transverse common tangent is given by under root d square minus r1 plus r2 whole square. So we have two circles, and first we'll talk about length of direct common tangent. Now this is line joining their centers, C1, C2, and D is the distance between centers. Here we have to find this length of direct common tangent, say AB. Now we'll draw perpendiculars to the centers. Now this is R1 and this is R2. Now what we'll do is, from this center C1, we'll draw a line parallel to AB. And suppose this point is P. Now this is 90. This is 90. This AC1 PB, it is a rectangle. So if this is L, this is also L. Now this is R1. This is also R1. Then this distance will be R2 minus R1. Now this is a right angle triangle. So in this right angle triangle, we can write L square equals D square minus R2 minus R1 whole square. Now this L is AB. So from here we can write length of direct common tangent AB will be equal to under root of D square minus R1 minus R2 whole square, which is what we need to prove in this first part. Now in the second part, we have to prove length of transverse common tangent. Now if we have transverse common tangent between the two circles, this is C1, C2, radius is R1 and R2, and we have a transverse common tangent between the two circles. Now this is point A and this is your point B. Now we extend this a bit and from C1 again we'll draw a line parallel to AB, and suppose this point is P. Now this is 90, this is R1, this is R1, and this is R2. So this PC2 is R1 plus R2, distance between centers is D, and this AB, it is equal to L. So from here we can write this L will be equal to this AB, and it is equal to under root of D square minus R1 plus R2 whole square. So this is length of direct common tangent, and this is the length of indirect or transverse common tangent. And there is this one case which is also very important, and which is when the two circles, they touch each other externally. Now when the two circles, they touch each other externally, in that case, distance between centers D, it is given as R1 plus R2. So in this case, length of direct common tangent, say AB, will be given by under root of D square, which is R1 plus R2 whole square minus R1 minus R2 whole square. Now here R1 square and R2 square will cancel. So it will be equal to 2 times under root of R1 R2. So if two circles, they touch each other externally, then in that case, length of direct common tangent, it is given by 2 under root of R1 into R2. Now here the question is, three circles with radius R1, R2 and R3 touch each other externally and they have a common tangent, then we have to find this value. So we have three circles which touch each other externally, and they also have a common tangent. Now R1 is the smallest, so suppose this is R1, this is R2, and this is R3. We have to find this condition. Now we can solve this question using either Descartes' theorem of kissing circles or using length of direct common tangent. Now we know that length of direct common tangent between two touching circles externally, it is given by 2 under root R1, R2. So suppose we have these points A, B, and C. Now for these two circles, we can write AB as twice under root R1, R3. BC is 2 under root R1, R2, and AC is 2 under root R2, R3. Now AB plus BC is equal to AC. So we'll get 2 under root R1, R3 plus 2 under root R1, R2. It is equal to 2 under root R2, R3. Now this 2 will cancel, and we'll divide everything with R1, R3. So we'll get under root of R1 upon R2 plus under root of R1 upon R3 will be equal to 1, and that's your option A. And this also becomes a standard result where we can write under root R1, and this is under root R2 plus under root R3 upon under root R2, R3 equals 1. So radius of this smaller circle R1, it will be R2, R3 upon under root of R2 plus under root of R3 whole square. तो डायरेक्ट कॉमन टेंजेंट में होता है अंडर रूट डी स्क्वायर माइनस R1 माइनस R2 होल स्क्वायर, और लेंथ ऑफ इनडायरेक्ट कॉमन टेंजेंट में होता है अंडर रूट डी स्क्वायर माइनस R1 प्लस R2 होल स्क्वायर. तो यहां से हम लेंथ ऑफ टेंजेंट्स निकाल सकते हैं. तो इसमें एक केस और बनता है जहां पे दो सर्कल्स का रेडियस बराबर है. तो अगर हमारे पास दो सर्कल्स हैं और दोनों एक दूसरे को इंटरसेक्ट नहीं करते हैं, लेकिन ये दोनों सर्कल्स का रेडियस बराबर है. तो सपोज ये है C1, ये है C2, और यहां पे रेडियस है आपका R और इसका भी रेडियस R है. तो ट्रांसवर्स कॉमन टेंजेंट में प्रॉब्लम नहीं है. तो ये जो पॉइंट आएगा ये बेसिकली इसका C1 C2 का मिड पॉइंट आएगा. बट यहां पे अगर हम डायरेक्ट कॉमन टेंजेंट्स ड्रॉ करते हैं तो डायरेक्ट कॉमन टेंजेंट्स ये C1 C2 के पैरेलल आएंगे. तो इसका मतलब यहां पे डायरेक्ट कॉमन टेंजेंट्स एक दूसरे को कभी भी इंटरसेक्ट नहीं करेंगे. तो अगर ये केस में हमको इसका इक्वेशन निकालना है तो बेसिकली हम क्या करेंगे, हम ये लाइन का स्लोप निकालेंगे. तो ये लाइन का स्लोप निकालने के लिए हमारे पास C1 C2 है, y2 माइनस y1 अपॉन x2 माइनस x1. तो इसको हम लिख सकते हैं f2 माइनस f1 अपॉन g2 माइनस g1. अब जैसे ही हमारे पास m आ गया तो ये दोनों लाइन्स इसके पैरेलल होंगे. तो इस लाइन को मान लेते हैं y इक्वल्स mx प्लस c, और कंडीशन ऑफ टेंजेंसी यूज करेंगे तो वहां से हम c का वैल्यू निकाल सकते हैं. तो यहां से c का वैल्यू निकालने के लिए हम कंडीशन ऑफ टेंजेंसी यूज करेंगे. कोई भी सर्कल के सेंटर से उसका परपेंडिकुलर डिस्टेंस उसके रेडियस के बराबर होना चाहिए. तो यहां से हमको c का वैल्यू भी मिल जाएगा. तो ये है आपका पहला केस. अब आते हैं हमारे दूसरे केस की तरफ, जहां पे सर्कल्स टच ईच अदर एक्सटर्नली. अब ये केस में दोनों सर्कल्स एक दूसरे को एक्सटर्नली टच करते हैं. तो ये है C1 और ये है C2. तो कंडीशन इसके लिए हमको पता है कि C1 C2 बराबर R1 प्लस R2. तो ये है इसका कंडीशन. अब ये केस में ये जो पॉइंट ऑफ कांटेक्ट है P, ये है R1 और ये है R2. तो पॉइंट ऑफ कांटेक्ट P C1 C2 को डिवाइड करता है R1:R2 रेशियो में इंटरनली। तो अगर आपको पॉइंट ऑफ कांटेक्ट निकालना है तो सीधे इंटरनल डिवीजन यूज कीजिए, वहां से आपको ये पॉइंट ऑफ कांटेक्ट मिल जाएगा। और यहां पे जो डायरेक्ट कॉमन टेंजेंट का पॉइंट ऑफ इंटरसेक्शन है, पॉइंट ऑफ इंटरसेक्शन ऑफ डायरेक्ट कॉमन टेंजेंट, सपोज क्यू वो C1 C2 को डिवाइड करता है R1:R2 रेशियो में एक्सटर्नली, जो कि हमारा पिछले केस में हमने देखा था। और यहां से हम टेंजेंट्स का इक्वेशन निकाल सकते हैं कि जैसे ये पॉइंट है और अगर ये टेंजेंट निकालना है तो C1 C2 का स्लोप निकालिए और प्रोडक्ट ऑफ स्लोप -1 से आपको ये परपेंडिकुलर लाइन का स्लोप मिल जाएगा। पॉइंट है, स्लोप है, इक्वेशन लिख सकते हैं। और डायरेक्ट कॉमन टेंजेंट्स का जैसे हमने पिछले केस में देखा, वहीं से हम डायरेक्ट कॉमन टेंजेंट्स की इक्वेशन निकाल सकते हैं। और इसमें अगर लेंथ ऑफ डायरेक्ट कॉमन टेंजेंट देखें, लेंथ ऑफ डायरेक्ट कॉमन टेंजेंट तो हो जाएगा अंडर रूट ऑफ, अब ये क्या है, C1 C2 है d, तो हो जाएगा d² माइनस R1 माइनस R2 होल स्क्वायर। अब ये d है R1 प्लस R2, तो इसको हम लिखेंगे अंडर रूट ऑफ R1 प्लस R2 होल स्क्वायर माइनस R1 माइनस R2 होल स्क्वायर, तो ये हो जाएगा 2 टाइम्स अंडर रूट R1 R2। तो अगर दो सर्कल्स एक दूसरे को एक्सटर्नली टच करते हैं तो वो केस में इनका लेंथ ऑफ टेंजेंट वो आएगा 2 टाइम्स अंडर रूट ऑफ R1 R2 के। और इसमें अगर लेंथ ऑफ इनडायरेक्ट कॉमन टेंजेंट देखें तो क्या हो गया अंडर रूट ऑफ d² माइनस R1 प्लस R2 होल स्क्वायर। अब d क्या है, R1 प्लस R2, तो ये हो जाएगा 0। तो क्लियरली यहाँ पे लेंथ ऑफ इनडायरेक्ट कॉमन टेंजेंट 0 है। तो यहाँ पे हमको ये याद रखना है कि अगर दो सर्कल्स एक दूसरे को एक्सटर्नली टच करते हैं तो वो केस में उनके डायरेक्ट कॉमन टेंजेंट का लेंथ आता है 2 अंडर रूट R1 R2। अब ये रिजल्ट हमको बहुत काम में आएगा कि जैसे एक लाइन है और दो सर्कल्स हैं जो इस लाइन को टच करते हैं और एक दूसरे को टच करते हैं। जैसे ये पहला सर्कल और ये दूसरा सर्कल, और ये दोनों एक दूसरे को टच करते हैं। सपोज इसका रेडियस है R1 और इसका रेडियस है R2। अब ये कहता है एक ऐसे सर्कल का रेडियस बताइए जो कि ये तीनों को टच करता हो। तो इस तरह के दो सर्कल्स होंगे, एक तो ये छोटा वाला और एक और होगा जो कि इस तरीके से बनेगा, जिसका रेडियस बहुत बड़ा होगा और ये इनको टच करेगा, मतलब ये लाइन को कहीं जाके टच करेगा और ये इस तरह के दो सर्कल्स आएंगे। तो अगर हमको ये छोटे वाले का ट्राई करना है तो जैसे सपोज छोटे वाले का रेडियस है R और ये पॉइंट ऑफ कांटेक्ट है A, B और C। ये दोनों सर्कल्स एक दूसरे को एक्सटर्नल टच करते हैं, तो यहां से AB निकाल सकते हैं जो कि उनका डायरेक्ट कॉमन टेंजेंट है। तो ये 2 टाइम्स अंडर रूट ऑफ R1 इंटू R। अब ये दोनों सर्कल्स भी एक दूसरे को एक्सटर्नल टच करते हैं, तो यहां से BC निकाल सकते हैं। तो ये 2 टाइम्स अंडर रूट R2 इंटू R। और हम AC भी निकाल सकते हैं क्योंकि ये दोनों सर्कल्स एक दूसरे को एक्सटर्नल टच करते हैं, तो ये 2 टाइम्स अंडर रूट R1 R2। अब क्लियरली AB प्लस BC है बराबर AC के, AB प्लस BC इट इज इक्वल टू AC। तो यहां से 2 टाइम्स अंडर रूट R1 R प्लस 2 टाइम्स अंडर रूट ऑफ R2 R इट इज इक्वल टू 2 टाइम्स अंडर रूट ऑफ R1 R2। तो यहां से 2 कैंसिल कर देते हैं, तो यहां से हम लिख सकते हैं कि आपका अंडर रूट R जो आएगा वो आएगा आपका अंडर रूट ऑफ R1 R2 अपॉन अंडर रूट ऑफ R1 प्लस अंडर रूट ऑफ R2, या फिर ये जो छोटे सर्कल का रेडियस आएगा ये आएगा आपका R1 R2 अपॉन अंडर रूट R1 प्लस अंडर रूट R2 होल स्क्वायर। तो हमने डायरेक्ट कॉमन टेंजेंट का फॉर्मूला यूज करके ये निकाल लिया। अब ये बड़े वाले का अगर निकालना है तो वो केस में आप कैसे मानेंगे कि ये एक सर्कल ऐसा, दूसरा सर्कल ऐसा और तीसरा सर्कल ऐसा। तो यहां पे ये है ए, बी और सी। तो इसका रेडियस है R1, इसका रेडियस है R2 और इसका रेडियस है R। तो यहां पे अगर AC निकालेंगे तो यहां पे भी AC इक्वल्स AB प्लस BC। अब AC है R1 और R का, तो ये जो है 2 टाइम्स अंडर रूट R1R। AB है R1 R2 का, तो ये 2 टाइम्स अंडर रूट R1 R2। और BC है R और R2 का, तो ये जो R एंड R2 2 टाइम्स, तो ये 2 कैंसिल हो गया। तो यहां से जो अंडर रूट R आएगा वो आएगा आपका अंडर रूट ऑफ R1 R2 अपॉन अंडर रूट ऑफ R1 माइनस अंडर रूट ऑफ R2। तो ये जो रेडियस आएगा वो आएगा आपका R1 R2 अपॉन अंडर रूट R1 माइनस अंडर रूट R2 होल स्क्वायर। तो ये दो एक्सटर्नल टचिंग सर्कल के डायरेक्ट कॉमन टेंजेंट का जो फॉर्मूला है वो आपको कई सारे सिचुएशंस में हेल्प करेगा। अब आते हैं तीसरे केस की तरफ। तो यहाँ पे ये दो सर्कल्स एक दूसरे को इंटरसेक्ट करते हैं दो अलग अलग पॉइंट्स पे, और ये क्वेश्चन पूछा भी जा चुका है, कंडीशन बताओ दो सर्कल्स एक दूसरे को दो पॉइंट्स पे इंटरसेक्ट करते हैं। तो क्लियरली कंडीशन ये है कि C1 C2 छोटा होना चाहिए R1 प्लस R2 से, और ये बड़ा होना चाहिए मॉड ऑफ R2 माइनस R1 से। तो ये कंडीशन है जहां पे दो सर्कल्स एक दूसरे को इंटरसेक्ट करते हैं। अब दूसरा है, इसमें सिर्फ दो ही कॉमन टेंजेंट्स आएंगे और वो आपके डायरेक्ट कॉमन टेंजेंट्स होंगे। तो इस केस में सिर्फ डायरेक्ट कॉमन टेंजेंट्स आएंगे, और इनका जो पॉइंट ऑफ इंटरसेक्शन है वापस से वहीं से आएगा कि C1 C2 को Q डिवाइड करता है R1:R2 रेशियो में एक्सटर्नली, और यहां से हम इक्वेशन ऑफ टेंजेंट्स भी निकाल सकते हैं जैसे हमने पहले निकाले। और वापस से लेंथ ऑफ डायरेक्ट कॉमन टेंजेंट तो ये हो जाएगा आपका अंडर रूट ऑफ D स्क्वायर माइनस R1 माइनस R2 होल स्क्वायर। अब कई बार सवाल बनता है लेंथ ऑफ कॉमन कॉर्ड निकालने का। तो जैसे हमारे पास दो सर्कल्स हैं और ये दोनों सर्कल्स इंटरसेक्ट करते हैं, सपोज ये है आपका C1 और ये है आपका C2, और मान लेते हैं कि इनके बीच का जो डिस्टेंस है वो है आपका D। तो आपको ये जो कॉमन कॉर्ड है इसका लेंथ फाइंड आउट करना है। तो इसको करने का एक तरीका ये हो सकता है कि जैसे ये है आपका रेडियस R1 और ये है आपका रेडियस R2, ये है AB और ये पॉइंट है आपका C। तो मान लेते हैं कि ये AC है H, ये C1C है आपका X और C2C है आपका D माइनस X। तो अगर पाइथागोरस थ्योरम यूज करते हैं तो यहां से हम लिख सकते हैं कि H स्क्वायर बराबर आएगा आपका R1 स्क्वायर माइनस X स्क्वायर के, और ये बराबर होगा R2 स्क्वायर माइनस D माइनस X होल स्क्वायर के। तो इसको सॉल्व करेंगे तो ये हो जाएगा आपका R1 स्क्वायर माइनस X स्क्वायर R2 स्क्वायर माइनस D स्क्वायर माइनस X स्क्वायर प्लस 2dx। अब यहाँ पे x स्क्वायर कैंसिल हो गया, तो यहां से हम x निकाल सकते हैं। तो आपका जो x है वो हो जाएगा आपका R1 स्क्वायर माइनस R2 स्क्वायर प्लस D स्क्वायर अपॉन 2d। तो सीधे पाइथागोरस थ्योरम यूज किया, यहां से हमारे पास x आ गया। अब r है x है, तो यहां से हम AC निकाल सकते हैं और AC का दुगना AB हो जाएगा। तो यहां से अगर हम लेंथ ऑफ कॉर्ड निकालें तो ये जो AB है वो हो जाएगा 2 टाइम्स ऑफ AC, तो ये 2 टाइम्स ऑफ अंडर रूट ऑफ R1 स्क्वायर माइनस X स्क्वायर। तो एक ये तरीका है लेंथ ऑफ कॉमन कॉर्ड निकालने का। दूसरा इसका जो तरीका है वो है डायरेक्ट फॉर्मूला कि आप लेंथ ऑफ कॉमन कॉर्ड निकाल सकते हैं ये फॉर्मूले का यूज करके। फॉर्मूला है अंडर रूट ऑफ डी स्क्वायर माइनस R1 माइनस R2 होल स्क्वायर इंटू R1 प्लस R2 होल स्क्वायर माइनस डी स्क्वायर अपॉन d, where d is distance between the centers and R1 and R2 are radius of two circles। और हमको पता है कि ये सर्कल्स इंटरसेक्ट करते हैं तो d का वैल्यू आपका R1 प्लस R2 से छोटा आएगा और मॉड ऑफ R1 माइनस R2 से बड़ा आएगा। तो यहां से भी हम लेंथ ऑफ कॉमन कॉर्ड निकाल सकते हैं। अब अगर इसमें डायरेक्ट फॉर्मूला यूज करते हैं तो हमें पता है कि पहले सर्कल का सेंटर है a,0 और दूसरे सर्कल का सेंटर है 0, b। तो यहाँ पे d जो है वो c1 c2 हो जाएगा अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर। अब यहाँ पे R1 है a और R2 है आपका b। तो डायरेक्ट फॉर्मूला कहता है लेंथ ऑफ कॉमन कॉर्ड इज अंडर रूट ऑफ डी स्क्वायर। अब डी स्क्वायर यहां पे कितना हो गया a स्क्वायर प्लस b स्क्वायर माइनस R1 माइनस R2 होल स्क्वायर। तो ये हो जाएगा a माइनस b होल स्क्वायर इंटू अब यहाँ पे R1 प्लस R2 कितना है a प्लस b, तो a प्लस b होल स्क्वायर माइनस a स्क्वायर प्लस b स्क्वायर अपॉन d, और d है आपका अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर। अब यहाँ पे a स्क्वायर b स्क्वायर कैंसिल कर देते हैं तो ये हो गया आपका अंडर रूट ऑफ 2ab, और यहां से भी आपके पास आएगा अंडर रूट ऑफ 2ab अपॉन अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर। तो ये जो लेंथ ऑफ कॉर्ड है ये हो जाएगा आपका 2ab अपॉन अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर, जो कि सेम आंसर है। तो या तो ये मेथड से सॉल्व कर सकते हैं या फिर ये डायरेक्ट फॉर्मूले से भी यूज कर सकते हैं। और आते हैं चौथे केस की तरफ जहां पे दो सर्कल्स एक दूसरे को इंटरली टच करते हैं। तो सर्कल्स टच इंटरनली, कंडीशन हमको ऑलरेडी पता है कि C1 C2 बराबर होना चाहिए मॉड ऑफ R2 माइनस R1 के। अब दूसरा है इसमें कि इनका पॉइंट ऑफ कांटेक्ट, कि जैसे ये पॉइंट P तो ये है C1 और ये है C2। तो ये पॉइंट ऑफ कांटेक्ट निकालने के लिए वो पॉइंट ऑफ कांटेक्ट डिवाइड करता है C1 C2 को R1:R2 रेशियो में एक्सटर्नली। तो यहां से आप ये पॉइंट ऑफ कांटेक्ट निकाल सकते हैं। और अब पॉइंट ऑफ कांटेक्ट आ गया तो वहां से आप इक्वेशन ऑफ टेंजेंट भी निकाल सकते हैं। अब क्योंकि ये पॉइंट सर्कल पे लाई करता है तो इक्वेशन ऑफ टेंजेंट आ जाएगा t = 0 से। या तो आप t = 0 से निकाल लो या फिर आप C1 C2 का स्लोप निकालो m1 और उसका परपेंडिकुलर ले लो, वहां से आपको परपेंडिकुलर का स्लोप मिल जाएगा। तो स्लोप है, पॉइंट है, तो पॉइंट स्लोप फॉर्म से आपको ये टेंजेंट का इक्वेशन मिल जाएगा। तो ये है आपका दूसरा तरीका टेंजेंट निकालने के लिए। और पांचवा कॉन्फ़िगरेशन कि जहां पे एक सर्कल कंप्लीटली दूसरे सर्कल के अंदर लाई करता है। तो कंडीशन है C1 C2 छोटा होना चाहिए मॉड ऑफ R1 माइनस R2 के। तो यहाँ पे बहुत ज्यादा सवाल नहीं बनते हैं। कभी कभी ये सवाल बनता है कि कंडीशन बताओ कि एक सर्कल दूसरे सर्कल के अंदर कंप्लीटली कंटेन्ड है। तो एक सर्कल दूसरे सर्कल के अंदर कंप्लीटली कंटेन्ड होगा अगर C1 C2 छोटा है मॉड ऑफ R1 माइनस R2 से। तो a circle is contained in another circle। तो तो यही केस है और इसमें कोई टेंजेंट नहीं है, तो इसमें हम आगे और कुछ भी डिस्कस नहीं करेंगे. Now the question is find the number of common tangents to these two circles. Now for this first circle C1 is 0 0 and radius is 2, and for the second circle center is at 3, 4 and its radius is under root of 9 plus 16 plus 24 and that will be 7. Now we find C1 C2. C1 C2 is 5 and it is equal to R2 minus R1. Now when C1 C2 is equal to R2 minus R1, that means these two circles, they touch each other internally. So in this case, there is only one common tangent possible. So answer to this question is this option B. Now here the question is find the equation of a circle whose radius is 3 and which touches this circle internally at the point -1, -1. Now center of this circle is at 2, 3 and its radius will be under root of 4 plus 9 plus 12, which is 5. So we have this circle with center at 2, 3 and radius equals 5, and we need to find equation of this circle whose radius is 3 and which touches this circle at -1, -1. So this is -1, -1. Now let this center be C dash. Now we have to find center of this circle. So this point is -1, -1 and say this is P and this is center of the circle which is at 2, 3. Radius is 5 and center of this other circle, it is C dash and its radius is 3 units. So this distance is 2 units. So basically this C dash, it divides it in the ratio 3:2. So center C dash will be given by this 3 into 2 minus 2 upon 5 and 3 into 3 minus 2 upon 5. So it will be 4 by 5 and 7 by 5. And once we have center and radius, we can write its equation as x minus 4 by 5 square plus y minus 7 by 5 square, and will be equal to 3 square, and that is the answer to this question. Now the question is find the equation of common tangents to these two circles. Now if we look at this first circle, center is at 1, 3 and its radius will be 1 unit. And for this second circle, center is at -3, 1 and radius is 3 units. Now if we find C1 C2, C1 C2 will be under root of 4 square 16 plus 4 and that will be 2 root 5. Now basically C1 C2, which is 2 root 5, it is greater than R1 plus R2, which is 4. That means these two circles, they do not intersect and they'll be drawn like this. Now this is C2, which is -3, 1 and this is 1, 3. Radius of this circle is 3 units and radius of this circle is 1 unit. Now first we'll find this point of intersection of their transverse common tangent or indirect common tangent. Now this point P, it will divide them in the ratio R2 is to R1. So it will divide them in the ratio 3:1. So coordinate of this point P will be 3 minus 3 is 0. And this is 3 into 3 9. 9 plus 1 10. So there will be 10 by 4 and which is 5 by 2. So we need to find equation of tangent passing through this point. Now suppose its slope is m. We can write y minus 5 by 2 equals mx Now we can write this equation as mx minus 5 plus 5 by 2 equals 0. Now perpendicular distance from center, it must be equal to its radius. So we find this perpendicular distance, it will be this m minus 3 plus 5 by 2 upon under root of 1 plus m square will be equal to 1, and if we square it, we'll get this as m minus 1 by 2 whole square and will be equal to 1 plus m square. Now this is m square plus 1 by 4 minus m, it is equal to 1 plus m square. Now this m square will cancel, so value of m will be minus 3 by 4. Now we can put this value here. So equation of this tangent will be y equals minus 3 by 4x plus 5 by 2, or simply 3x plus 4y equals 10. So that is one of this transverse common tangent. Now here we have a problem. Problem is we are expecting two tangents and there has to be two tangents, but then from this equation we are getting only one value of m, and that is minus 3 by 4. So where is this other tangent? Now if we look at this expression is also valid if this limit m tends to infinite. If we take this limit m tends to infinite, then value of this limit is coefficient of m in the numerator, coefficient of m in the denominator, which is 1. So there is this another solution where slope is infinite. So essentially it is a line which is parallel to y-axis, and the line parallel to y-axis is x equals 0. So equation of another tangent is given by x equals 0. So these are two indirect common tangents. Now we'll find direct common tangents. Now for direct common tangents, we have to find this point, say Q, and this point Q will divide these centers 3, 1 and 1, 3 in the ratio 3:1 externally. So coordinate of this point Q will be this 3 plus 3 is 6, 6 upon 2 is 3, and here will be this 9, 9 minus 1 is 8, 8 upon 2 is 4. So coordinate of this point Q is 3, 4. Now once we have this point, we will find equation of these tangents. These are just horrible tangents, so please don't mind. Now suppose the slope is m, we can write this equation as y minus 4 equals m x minus 3, or we can write this equation as mx minus y plus 4 minus 3m equals 0. Now again, perpendicular distance from center will be equal to its radius. So if we put x as 1 and y as 3, we'll get m minus 3 plus 4 minus 3m upon under root 1 plus m square, and it will be equal to 1. So basically it is mod of 1 minus 2m, it is equal to under root of 1 plus m square. And we square it, we'll get 1 plus 4m square minus 4m, and that will be 1 plus m square. Now this 1 and 1 will cancel, we'll get this as 3m square minus 4m equals 0. So the two values of m are 0 and 4 by 3. Now if you put m as 0, we'll get one of the tangent as y equals 4, and if you put m as 4 by 3, we'll get this equation as y minus 4 equals 4 by 3 x minus 3, and that will be simply 3y equals 4x. So these are the equation of 4 tangents to these circles. Now here the question is, if the length of common internal tangents to the circle is 7 and length of common external tangents is 11, then product of radius of two circles is. Now we know that length of indirect common tangent or transverse tangents is given by under root of d square minus r1 plus r2 whole square, where d is distance between these centers. Now this is equal to 7, or we can write d square minus r1 plus r2 whole square will be equal to 49. And length of direct common tangent, it is given by under root of d square minus r1 minus r2 whole square. And in this case, it is given as 11. So this d square minus r1 minus r2 whole square, it is 121. Now what we'll do is, we'll subtract first from second. So it will be this minus plus and minus. So this d square will cancel. So we'll get 4r1 r2 and will be equal to 121 minus 49, which is 72. And 72 divided by 4 is 18. So basically r1 into r2 is 18, and that's your option C. Now here the question is number of common tangents to these two circles. Now for this first circle, center is at 1, 0 and radius is 1. And the second circle, center is at minus 3, 3 and its radius will be 18 minus 2 is 16. It is 4. I'll find C1, C2. C1, C2 is 4 square plus 3 square, which is 5. So C1, C2 is basically equal to R1 plus R2. And if C1, C2 equals R1 plus R2, that means these two circles, they'll touch each other externally. In that case, they'll have 3 common tangents. 1, 2 and 3. So number of common tangents will be 3. So this A, it matches with R. So that's your A. Now for B, it says number of indirect common tangents of these two circles. Now center of this first one is 2, 5 and its radius is 5. C2 is 3, 6 and R2 is 36 plus 9, 45, 45 plus 55, 100, that will be equal to 10. Now we find C1, C2. C1, C2 is under root of, now this is 1 plus 1, that is root 2. Now C1, C2 is less than R2 minus R1. That means one circle is contained in the other. So there will be no indirect common tangent. So this B, it matches with S. So this B, it matches with S. Now this third one is center at 1, 2 and radius equals under root 5. And this one is 0, 4 and R2 is 16 plus 4, 20, which is 2 root 5 and C1, C2 is 1 plus 4 under root 5. Now basically C1, C2 is R2 minus R1. That means these two circles, they touch each other internally. In that case, they'll have only one common tangent. So this C, it matches with B. So this C, it matches with B. And finally, number of direct common tangents to these circles. So for D, center is at minus 1, 4 and its radius will be under root of 1 plus 16 minus 13, which is 2, and C2 is 3, 1 and R2 is under root of 9 plus 1 minus 6, which again is 2. Now we find C1, C2. C1, C2 is 4 square plus 3 square, which is 5. Now here C1, C2 is greater than R1 plus R2. That means these two circles, they do not intersect. So in this case, number of direct tangents is 2. So this D, it matches with Q. Now here the question is, let point B be the reflection of point A with respect to this line. So we have this point A, which is 2, 3, and this line say L, which is 8x minus 6y minus 23 equals 0. Now reflection of this point about this line L is B. So we'll use image of a point formula. So it will be this x minus 2 upon 8, y minus 3 upon minus 6, and then minus 16 minus 18 minus 23 upon 64 plus 36. That will be 100. Now this is 25, 50. This value is 1 by 2. Now this is 4 plus 2, 6. So coordinate of this point B will be 6. And here this is minus 3 plus 3, 0. So coordinate of point B is 6, 0. Now it says let tau A and tau B be circles of radius 2 and 1 with centers at A and B respectively. So we have this point A, which is 2, 3, and we have circle of radius 2 drawn from it as a center, and then we have this other point B, which is 6, 0, and here its radius is 1 unit. Now it says T is a direct common tangent between the two circles. And this direct common tangent intersects this line joining AB at this point C. We have to find this AC. Now we know that this C, it is going to divide AB in the ratio R1 is to R2. So we'll divide AB in the ratio 2 is to 1 externally. So coordinate of this point C will be 12 minus 2 upon 1. L be 0 minus 3, and here it is this 1. So coordinate of this point C, it is 10, minus 3. Once we have A and C, we can find AC. So this AC will be under root of, now this is 10 minus 2, 8. So it will be this 8 square, and plus 3 minus 3 is 6. 6 square, there will be 100. So this value is 10. So length of this line segment AC is 10, and that is the answer to this question. And this question, it says let ABC be a triangle with AB equals 1, AC equals 3, and BAC equals pi by 2. If a circle of radius r greater than 0 touches the sides AB and AC and also touches internally the circumcircle of triangle ABC, then the value of r is. What we'll do is, since it is a right angled triangle, we'll take this triangle along axis of coordinate. Now angle A is 90, so this is A, this is B, and this is C. Now suppose A is at origin, B is at 1, 0, and C is at 0, 3. And if we take its circumcircle, and we know that center of the circle will be midpoint of BC. So this center will be 1 by 2 and 3 by 2. And this length of BC is under root 10, which is diameter of the circle. So radius of this circle will be under root 10 by 2. Now it says we need to find radius of a circle which touches these two sides and also this circle. Now we know that any circle which touches both the axes, its center will be r, r, since in this case we are dealing with first quadrant, and its radius will also be r. Now these two circles, they touch each other internally, and if the two circles touch each other internally, then C1, C2, it must be equal to R1 minus R2. So basically C1, C2, it must be equal to R1 minus R2, and R2 in this case is R. Now C1, C2 is under root of R minus 1 by 2 square plus r minus 3 by 2 square, and it will be equal to under root of 10 by 2 minus r. Now we square this, we'll get r square plus 1 by 4 minus r plus r square plus 9 by 4 minus 3r, and this is 10 by 4 plus r square minus under root 10r. Now 1 by 4 plus 9 by 4 is 10 by 4. So this 10 by 4 and 10 by 4 will cancel. R square will also cancel. So we'll get this as r square equals 4 minus under root 10 r. Now r cannot be 0. So from here we'll get the value of r as simply 4 minus under root 10. And 4 minus under root 10 is nearly 0.84. So answer to this question is 0.84. Now here the question is, three circles with radius r1, r2 and r3 touch each other externally and they have a common tangent. Then we have to find this value. So we have three circles which touch each other externally and they also have a common tangent. Now r1 is the smallest, so suppose this is r1, this is r2 and this is r3. We have to find this condition. Now we can solve this question using either Descartes' theorem of crossing circles or using length of direct common tangent. Now we know that length of direct common tangent between two touching circles externally, it is given by 2 under root r1, r2. So suppose we have these points A, B and C. Now for these two circles, we can write AB as twice under root r1, r3. BC is 2 under root r1, r2 and AC is 2 under root r2, r3. Now AB plus BC is equal to AC. So we'll get 2 under root r1, r3 plus 2 under root r1, r2. It is equal to 2 under root r2, r3. Now this 2 will cancel and we'll divide everything with r1, r3. So we'll get under root of r1 upon r2 plus under root of r1 upon r3 will be equal to 1, and that's your option A. And this also becomes a standard result where we can write under root r1 and this is under root r2 plus under root r3 upon under root r2, r3 equals 1. So radius of this smaller circle r1, it will be r2, r3 upon under root of r2 plus under root of r3 whole square. Now here the question is, given a circle x plus 4 whole square plus y minus 2 square equals 25. So we have this circle whose center is at minus 4, 2 and radius is 5. Another circle is drawn passing through the point 4, 2, which is its center, and touching the given circle internally at the point minus 4, 7. So it is this circle. Now it says AB is a chord of length 8 units of the larger circle intersecting the other circle at this point C, then AC will be. So we have this chord AB which intersects this circle at this point C. We have to find length of AC. Now basically it is diameter and this is 5. Now this point C, it is on semicircle, so this angle is 90 and length of AB is 8 units. And if length of AB is 8 and this is perpendicular, so this is 4 and this is 4. So length of AC is simply 4, and that is the answer to this question. Question: centers of two circles C1 and C2, each of unit radius, are at a distance of 6 units from each other, and let P be the midpoint of line joining centers of C1 and C2, and C be a circle touching C1 and C2 externally. If a common tangent to C1 and C passes through P is also a common tangent to C2 and C1, then radius of this circle C is. So here we have two circles with centers at C1 and C2, and P is the midpoint, and radius of these circles, they are 1 unit. So this is 1 and this is 1. Suppose this P is at origin, then this point C1 will be minus 3, 0 and C2 is 3, 0, and radius for both the circles, they are 1 unit. Now it says there is this another circle C which touches both the circles. So there is this another circle C which is going to touch both the circles. Now so center of the circle is at H, K. Now if we join these two centers, and suppose this point is A, now it says common tangent to C1 and C passes through P and is also a tangent to this second circle C2. So it's also a tangent to this second circle C2. Then radius of circle C is. Now suppose this radius is R. Perpendicular from the center, it'll pass through P. This is 1. This is 3. And this angle is suppose alpha. This is 90. This is 90. This is 90 minus alpha. Then this angle will be alpha. And this angle will also be alpha. Now in this triangle AC1P, we can write sine alpha, and value of sine alpha is 1 by 3. And if we draw this triangle, this is 1, this is 3, and this is 2 root 2. So if we write cos alpha is 2 root 2 upon 3. And this triangle we can write AP. Now this AP is 3 cos alpha, and 3 cos alpha is 2 root 2. Now for this triangle CPA, we can write R equals AP cot alpha. Now AP is 2 root 2 and cot alpha is 2 root 2 upon 1. So value of R is 8. So radius of this larger circle C is 8 units. And that is the answer to this question. Now here this part A is diameter of circle touching this line, and this line is x minus 1 cos theta plus y minus 1 sin theta and minus 1 equals 0. Now if we write perpendicular distance from any point, say HK, then perpendicular distance will be h minus 1 cos theta plus k minus 1 sin theta minus 1 upon under root of cos square theta plus sin square theta, which is 1, and will be equal to radius of the circle. Now this should be true for all the values of theta. So it is possible if and only if h is 1 and k is 1. And if h is 1 and k is 1, then the value of r is 1. So diameter of the circle will be simply 2. So this A, it matches with P. Now B is radius of the smallest circle which touches the given two circles. Now this first circle has center at origin and its radius is 1. And the second circle, center is at 3, 4. And here radius will be 2. Now radius of smallest circle which is going to touch these two circles will be given by this circle. Now this distance C1, C2, it is 5. Radius of first circle is 1 and radius of second circle is 2. So this distance, it is 2 units and its radius will be 1 unit. So this B, it matches with Q. So this B, it matches with Q. Now C is number of values of M for which this line cuts the circle at 2 real points. Now for the C part, we know that this line, it passes through this point 1, 2 and point 1, 2, it lies on this circle. So this is 1 plus 4 equals 5. So from this point, there can be infinite lines which are going to intersect this circle at 2 points. So this C, it matches with S. And D is number of circles touching both the axis and this line x plus y equals 4. So we have this line x plus y equals to 4 and you want number of circles touching both the axis and this given line. So this is one circle. Another circle could be drawn like this. Then we have this circle. And we also have this condition. Now, no circle is possible in this third quadrant. So number of such circles possible is simply 4. That means this D, it matches with R. So this D, it matches with R. So answer is PQSR. Now here the question is, consider two fixed circles, x square plus y square plus 4 mod x plus 3 equals 0. Center is at plus minus 2 comma 0 and radius is 1 unit. So we have two circles with centers at minus 2 comma 0 and plus 2 comma 0 and radius equals 1 unit. Now it says a triangle ABC is initially located so that its vertices have the following positions. Now C is at this point, minus 2 comma 2 plus 2 root 3 and this B, it is at 2 comma 2 plus 2 root 3. Now basically it is a line which is parallel to x-axis. And then point A, it is at 0 comma 2. That's your y-axis. And we have this triangle. Now slope of this line, it is 2 root 3 upon 2 root 3. So this angle is 60. And here this slope, it is minus root 3 120. So this angle, it is 60 degrees. So basically it's an equilateral triangle. Now it says it starts translating downwards perpendicular to the x-axis and stops when its edges hit the circle AB at the point P1 and AC at point P2. So this triangle, it starts coming down till it becomes something like this. We'll redraw this circle like this. Now this point is say P1 and this point is your P2. This is A and this is B. Now we have to find the ratio in which P1 divides AB. Now we'll drop this perpendicular here, and this is 90. We know that this angle is 60, so this angle will be 30, and radius of this circle is 1 unit. So if we write P1B will be 1 chord 30, and that will be simply √3. Now length of AB, it is 4 units using distance formula. Then length of P1A is 4 minus √3. Now we have to find the ratio of P1A upon P1B. So we have to find P1A upon P1B. Now this is 4 minus √3 upon, now P1B is √3. So answer to this question is 4 minus √3 upon √3, and that's your option B. Now here the questions: let each of the circles touch the other two, and P1, P2, P3 be the points of contacts of S1 and S2, S2 and S3, and S3 and S1 respectively, and let C1, C2, C3 be the centers of S1, S2, S3. Now C1 is 0, -2, and its radius is √5. C2 is -3, -1/2, and its radius is 9 + 1/4 -8. So 1 + 1/4 is √5/4. So R2 is under √5/2, and C3 is 2, 2, and its radius is 37 + 8 under √45, which is 3√5. So this R3 is 3√5. Now this C3, it is a bigger circle, and the other two circles, they touch C3 internally and they touch each other externally. So this is C3, and then we have C1 and C2. So this is C1 and this is C2. Now S1, S2 did touch at P1, so this point is P1, S2, S3 at P2, and this point is P3. So we have these two triangles, C1, C2, C3, and P1, P2, P3. Now first we have to find coordinate of P1. Now P1 is point of contact of these two circles. Now C1 is 0, -2, and C2 is -3, -1/2, and this P1, it divides C1, C2 in the ratio R1 is to R2 internally. So it will divide them in the ratio 2:1. Now this is -6/3, -2, and here will be this -1, -2, -1. So coordinate of P1 is -2, -1, and that's your option D. Now in the same way we can find P2 and P3. Now C3 is 2, 2, C2 is -3, -1/2, and this point P2, it divides it in the ratio R3 upon R2 externally. So we'll divide it in the ratio 6:1 externally. Now this is -18, -2, -20, -20 upon 5 is -4. and here will be this minus 3, minus 2, minus 5, minus 4, minus 5 upon 5 is minus 1. So this point P2 is minus 4 comma minus 1. And we can also find this P3. Now P3 is going to divide C3 C1 in the ratio C3 upon C1, which is 3:1 externally. Now this is 2 comma 2 and this is 0 comma minus 2. So it will be 3 minus 2 upon 2. So this is minus 1 and here it is minus 6 minus 2. Minus 8 upon 2 is minus 4. So this point P3 is minus 1 comma minus 4. So now we have coordinate of all the 3 points. So this P1 is minus 2 comma minus 1. Now it says ratio of areas of these two triangles is. Now area of triangle formed by C1, C2, C3 is suppose delta 1. So it will be this 1 by 2, 0, minus 2, 1, minus 3, minus 1 by 2, 1, and then 2, 2, and 1. So this area will be 1 by 2 and then 2 into minus 3, minus 2, minus 5, plus 1, and here will be this minus 6, plus 1. So it will be minus 10, minus 5, minus 15 by 2, and we take this area positive, so it will be 15 by 2 square units. Now we'll find area of P1, P2, P3, which is say delta 2. And this area will be this 1 by 2, and this is minus 2, minus 1, 1, minus 4, minus 1, 1, and then minus 1, minus 4, 1. Now if we add these two rows, we'll get this 0, 0, and minus 3. So it will be this minus 3 by 2, and this is 2 minus 4 minus 2. So this area will be simply 3. Now we have to find ratio of these areas, delta 2 upon delta 1. Now delta 2 is 3 and delta 1 is 15 by 2. So this ratio, it is 2 by 5. And that's your option B. And it says P2 and P3 are image of each other with respect to line. Now we know that P2 is minus 4 comma minus 1 and P3 is minus 1 comma minus 4. So basically here we have interchanged x and y, and we know that we get it by reflecting about this line y equals to x. So this third option, it is this option C. Now here the question is, we need to find radius of the circle having center at 2, 1, whose one of the chord is the diameter of this circle. So we have this circle, and suppose this is diameter of this circle. Center is at 1, 3, and its radius is 1 plus 9 minus 6, which is 2. Now radius of this circle, it is at 2, 1, and it passes through this diameter of other circle. Now if you look at this distance is say D, and it is given by under root of 1 plus 4, which is under root 5. So value of D is under root 5. Now we need to find this radius, say R. Now radius of this circle is 2, this D is 5. So value of capital R is under root of 5 plus 4, which is 9. So this radius is 3 units, and that's your option C. Now here the question is, if C1, C2 are circles of unit radius with center at 0, 0 and 1, 0. So we have two circles with centers at 0, 0 and 1, 0. So we have this one circle and then this other circle, and radius of both the circles is 1 unit. That says C3 is a circle of unit radius passing through centers of C1 and C2. Now this is C1 and this is C2, and we have this third circle which passes through centers of C1 and C2, and its radius is also 1 unit. Now we have to find equation of common tangents to C1 and C which does not pass through C2. So basically we have to find equation of this tangent. Now we know that center of this third circle will pass through this line, which is a line passing through midpoint of 0, 0 and 1, 0. So this point is 1 by 2, 0. So x coordinate for the center, it will be given by 1 by 2, and suppose this is k. Now we know that distance from center to any point on the circle, it is equal to 1 unit. So we'll get 1 by 4 plus k square equals 1, or k square is 3 by 4. Value of k is plus minus root 3 by 2, and since this center, it lies above x-axis, so it is root 3 by 2. So center of this third circle will be at 1 by 2, root 3 by 2. Now since both the circles, they have equal radius, this tangent will be parallel to line joining their centers. So we can find slope of line joining their centers, and suppose it is m. So this value will be simply root 3. So that means slope of this line is also root 3. And once we have slope of line, we can find equation of this tangent for this circle, x square plus y square equals to 1, using slope formula. So we know that equation of tangent is given by y equals m x plus minus r under root 1 plus m square. So this equation will be y equals root 3x plus or minus 2. Now there will be two such tangents. We are interested in this tangent where y-axis intercept is positive. So equation of this tangent is given by y equals root 3x plus 2 or root 3x minus y plus 2 equals to 0, and that's your option B. Now it says the two circles intersect in two distinct points. Now we know that two circles, they'll intersect at two distinct points if C1, C2, it is greater than mod of R1 minus R2, and it is less than R1 plus R2. Now here C1 is 1, 3 and C2 is 4, minus 1. R1 is R and R2 is 16. 16 plus 1, 17. 17 minus 8, 9. So this radius is 3. Now this is mod of R minus 3 and will be less than C1, C2. Now C1, C2 is 3 square plus 4 square, which is 5. And then R1 plus R2 is R plus 3. So from here we can say this R, it must be greater than 2, and mod of R minus 3 will be less than 5, then minus 5, R minus 3 should be less than 5, or R should lie between minus 2 and 8. Now R cannot be negative and R is greater than 2. So the condition that we get from here is value of R must lie between 2 and 8, and that's your option A. Now here the question is, if PQR is a triangle formed by common tangents to these two circles, then which of the following is correct? So we're given two circles. Both the centers, they lie on x-axis. Center for the first one is minus 3, 0. And for the second one, it is 1, 0. Its radius is 3. And for the second one, radius is 1 unit. So they'll be touching each other at origin. Have you defined? This triangle formed by their common tangents. One of the common tangent is this y-axis itself. So we are talking about this triangle. P, Q, and R. Now we are given two centers C1 and C2. Now this point P, it'll divide C1, C2 in the ratio 3:1 externally. So we can find this point P. So this is 3 into 1 plus 3 upon 2. So that'll be 3 and this is 0. So this point P is 3, 0. Now this is origin, and what we'll do is we'll find this angle OPQ. Let it be theta. So we'll drop a perpendicular from 1, 0 to its tangent. Its radius is 1 and this distance is 2. So we can write sine theta as 1 by 2. And if sine theta is 1 by 2, that means theta is pi by 6. And if theta is pi by 6, that means angle P is 60 degrees. Now if this angle P is 60 degrees, these two sides they're equal. That means angle Q and angle R, they're also 60. So this triangle PQR will be an equilateral triangle. Now this is in circle, so its in radius will be 1 unit. Its in center is at 1, 0 and its in radius is 1 unit. And also it is an equilateral triangle. So all the center they'll be at in center. So its centroid will also be at 1, 0. So option A is correct, option B is correct, and option D is correct. Now its circumradius will be equal to C2P and this is 2. So that means this option C is also correct. Now the question is two circles of radius A and B touching each other externally are inscribed in the area bounded by y equals under root 1 minus x square, which essentially is a semicircle and x-axis, and it says if b is 1 by 2, then 4a is equal to what? So we'll draw the semicircle whose center is at origin and radius 1. So these two coordinates, they'll be 1, 0 and minus 1, 0. Now this is 0, 1. And since b is 1 by 2, and which is a radius of one circle, its diameter will be 1. So that means that circle can only be drawn with endpoints of diameter as 0, 1 and 0, 0. So that's your second circle whose radius is b. So this is how we can draw this circle. We'll join these 2 points. Let the center be C1 and its radius is 1 by 2. So this is 1 by 2 and this is 1 by 2. Now we'll draw this smaller circle whose radius is A. And suppose its center is C2. Now we'll join this perpendicular on x-axis and C1, C2. Now this is A and C1, C2 will be A plus 1 by 2. Now we'll join C2 with O and extend it. Now this entire radius is 1 unit and radius of this smaller circle is A. So this OC2 will be 1 minus A. Now from this C2 we'll drop a perpendicular on OC1. Now this distance will be simply 1 by 2 minus A. Let this point be A and the other point be B. Now in this right angle triangle C2B C1, we can write C2B square as this C1 C2, which is A plus 1 by 2 square minus 1 by 2 minus A whole square. Now we simplify this, we'll get this as 2A. Now the C2B is same as OA, which we can find from this triangle OAC2. So this OA square will be 1 minus A square minus A square. So there will be 1 minus 2A. Now both the lengths, they are equal. So if we equate them, we can write 1 minus 2A equals 2A. Or 4A equals 1. So the value of 4A is 1. Now here the question is, if C1, C2 are two circles of radius A and B respectively touching both the coordinate axis and their centers in first quadrant. So here we have coordinate axis. We have this circle C1, and then we have this other circle C2, which touches this circle, and also these two axes. Now basically C1 will have center at a comma a, and its radius is a, and C2 is at b comma b, and its radius is b. Now we know that if they touch each other externally, then C1 C2 it is equal to R1 plus R2. Now C1 C2 will be b minus a root 2, and this is equal to b plus a. Then we can write b into root 2 minus 1, it is equal to a into root 2 plus 1. So essentially b upon a will be equal to root 2 plus 1 upon root 2 minus 1, or we can write this as 3 plus 2 root 2. That means this option A, it is correct. So that's your part A. Now for this part B, it says C1, C2, they are orthogonal. So if they are orthogonal, in that case, C1, C2 square, it is equal to R1 square plus R2 square. Now C1, C2 square is b minus a square into 2, and it is equal to a square plus b square. So now we'll get this as a square plus b square minus 4ab equals 0, or we can write b upon a whole square minus 4 b upon a plus 1 equals to 0. Now b upon a will be b plus minus under root of b square minus 4ac upon 2. So there will be 2 plus minus root 3. And since b is greater than a, we have to choose plus sign. So in this case, b upon a will be 2 plus root 3. That means this option B is also correct. Now C is, if C1, C2 intersect in such a way that their common chord has maximum length, then B upon A is. Now if common chord has maximum length, then in that case, this common chord will be diameter of this first circle. So these two circles, they'll be drawn like this. Because for these two circles, common chord cannot be greater than diameter of smaller circle. Now this is b comma b, and this is a comma a, and this is a. And this is b. So in this case, a square plus c1 c2 square will be equal to b square. Now c1 c2 square is b minus a whole square into 2, and this is b square minus a square. Now it will be 2b minus a equals b plus a, or b equals 3a. In this case, value of b upon a will be equal to 3. So for this third part, it is given that this b upon a, it is equal to 3. That means this option C is also correct. Now D is, if C2 passes through center of C1, then b upon a is this value. Now for this fourth part, we given that this C2, it passes through center of C1. Now this is a comma a, this is b comma b, and here distance between them will be equal to b. So here C1 C2, it is equal to b, and C1 C2 is b minus a root 2, and it is equal to b. So this b upon a will be root 2 upon root 2 minus 1, or this is 2 plus root 2. That means this option D is also correct. Now here the question is, if the circle C1 touches x-axis and this line y equals x tan theta in the first quadrant, and circle C2 touches y equals 10x and y-axis, and circle C1 in such a way that ratio of radius to C1 to radius of C2 is 2:1. Then the value of tan theta is under root a minus b upon c. Then we have to find the value of a plus b plus c by 11. Now we have coordinate axis. And then we have this line y equals x tan theta. And this angle will be theta. Now there is this circle C1 which touches x-axis and this line, and we have this other circle C2 which touches y-axis, this line and this circle. So this is C1 and this is C2. Now we have to find the value of tan theta by 2, and it is given that R1 is to R2 is 2. Now if we join these, then this angle, this is theta by 2 and this is pi by 2 minus theta. So this half angle will be pi by 4 minus theta by 2. That means angle between these two dotted lines, it is pi by 4. Now we join these. This is 90 and this is 90. Now suppose this common side of two triangles, its length is x. Then in this first triangle we can write tan pi by 4 minus theta by 2 will be equal to R2 upon x. And in the second triangle, we can write tan theta by 2 will be equal to R1 upon x. Now what we'll do is, we'll divide first with second. So we can write tan pi by 4 minus theta by 2 upon tan theta by 2 will be equal to R2 upon R1, and this value is 1 by 2. Now this is 1 minus tan theta by 2 upon tan theta by 2 upon 1 plus tan theta by 2, and it is equal to 1 by 2. Now we have to find the value of tan theta by 2, so we take tan theta by 2 as x, so it will be this x square plus x, and it will be equal to 2 minus 2x, where x is tan theta by 2. Now this equation is x square plus 3x minus 2 equals 0, or the value of x will be minus 3 plus minus under root 9 plus 8 whole divided by 2. That is, value of x is minus 3 plus minus under root 17 by 2. Now theta by 2 is an acute angle, so we will choose positive value. So value of x here will be minus 3 plus under root 17 by 2. So in this case, value of tan theta by 2 is minus 3 plus under root 17 by 2. Now if we compare it, we'll get a as 17, b as 3 and c as 2. Now a plus b plus c by 11 will be 22 by 11, which is simply 2. So answer to this question is 2. Now this is a very simple and conceptual question that says two intersecting circles. So if we have two intersecting circles, they'll have a common normal which will pass through their centers, and they'll also have their common tangent. So this A, it matches with P and Q. B is two mutually external circles. Now if we have two mutually external circles also, Then also we can draw a line passing through their centers, which is going to be their common normal. So they'll have a common normal and they'll again have 4 common tangents. So this B, it also matches with P and Q. Now see 2 circles, one strictly inside the other. So if we have 2 circles where one of the circle lies completely inside the other, then in that case we can always form a line joining the 2 centers. So they'll have a common normal, but they won't have any common tangent. So this C, they'll have a common normal Q, but they do not have a common tangent. So this C, it matches with QR. And D is 2 branches of a hyperbola. Now if we take 2 branches of a hyperbola, this x-axis or their axis is their common normal at vertices. So they'll have a common normal. So this D, it'll have Q, but then these 2 branches, they can never have a common tangent. The best they have is this asymptote, which appears to meet them at, so they do not have a common tangent. So it also matches with QR. Now here the question is, we are given a circle x square plus y square equals 4, center at origin and radius equals 2. And we have this other circle with center at 3, 0 and radius equals 1. So we have these 2 circles. Now it says a tangent PT is drawn to this circle at this point P. Now this point P, it lies on the circle. Then equation of tangent at this point P, it is given by t equals 0 and there will be root 3x plus y equals 4. Now it says a straight line perpendicular to PT is tangent to this other circle. Now slope of this line is minus root 3. Then the slope of line which is perpendicular to this line will be 1 by root 3. So we have to find equation of tangent to this other circle whose slope is 1 by root 3. Now we know that equation of tangent is given by y equals m x minus 3 plus minus r under root 1 plus m square. So it will be this y 1 by root 3 x minus 3 plus minus, and this is 1 plus 1 by 3. So we'll get this as root 3y minus x plus 3 and it will be equal to plus or minus 2. Now if we take this plus sign, equation of this line will be x minus root 3y minus 1 equals 0, and if we take minus sign, then it will be x minus root 3y minus 5 equals 0. So a possible equation for this line is this option A. Now this next one is a common tangent to these 2 circles. Now one of the common tangent is at their point of contact, and this is simply x equal to 2, which is not given. So here we have to find equation of other common tangents. Now equation of tangent to this first circle is y equals mx plus minus r under root 1 plus m square, and for the second circle it is y equals m x minus 3 plus minus 1 under root 1 plus m square. Now both the equations, they should represent the same line. So here we get plus minus 2 under root 1 plus m square will be equal to minus 3m plus minus under root 1 plus m square. Now here we'll have 2 scenarios. Scenario 1, if these 2 they have same sign, then we'll get under root 1 plus m square equals minus 3m. So we'll get 1 plus m square equals 9m square. In that case, value of m is plus minus 1 upon 2 root 2. So in this case, equation of tangent will be y equals plus minus 1 upon 2 root 2 x. and here will be this minus plus, because when slope is positive, intercept is negative, and when slope is negative, intercept is positive. 2 under root 1 plus m square. So it will be 2 under root 1 plus 1 by 8. So we'll get this as 2 root 2y equals plus minus x minus plus 6. So if we take minus here and plus here, we get x plus 2 root 2y equals 6. That means it is this option D. And if we consider this second case, when they are of opposite sign, then we get 3 under root 1 plus m square equals minus 3m. Now in this case, we won't get any tangent. So answer to this question is option A and D. Now here the question is, 3 circles of radius A, B and C, where A is less than B is less than C, touch each other externally and they have x-axis as their common tangent. So here we have 3 mutually tangential circles. And radius of this circle is A, radius of this circle is B, and radius of this larger circle is C. And suppose their points of contact are A, B and C. Now we know that length of direct common tangent between two external touching circles is given by 2 times under root R1, R2. So in this case, this AC, it is given as 2 under root AC. AB is given as 2 under root AB, and BC is given as 2 under root BC. Now we know that BC is AC plus AB. So we can write 2 times under root BC will be equal to 2 times under root AC plus 2 times under root AB. Now this 2 will cancel. Now we'll divide everything with under root ABC. So we'll get 1 upon under root A will be equal to 1 upon under root B plus 1 upon under root C, and that's your option B. Now here the question is, let the circle C1, C2 intersect at points X and Y, and suppose that another circle X minus H square plus Y minus K square equals to R square satisfy the following conditions. Center of C3 is collinear with centers of C1 and C2. C1 and C2 both lie inside C3, and C3 touches C1 at M and C2 at N. So basically we have 2 given circles, and this first circle center at origin, and radius 3 units. This second circle with center at 3, 4 and radius 4 units. So here this radius is 3 and this radius is 4 units, and distance between center is 5. So basically this angle is 90 degrees. Now it says we have another circle whose center is C3, which is collinear with centers of C1 and C2, and C1 and C2 both lie inside C3 and it touches them at M and N. So we have this circle which is going to contain both the circles and which is going to touch both of them at M and N. So this point is M and this point is N. Now we know that this distance is 5, this is 3 and this is 4. So radius of this bigger circle will be 6 unit. So radius of this larger circle, it is 6 units. Now this is 2 and this is 3. So this C3, it divides origin and 3, 4 in the ratio 3:2. So center of the circle C3 will be at 9/5 and 12/5. So for this third circle, we have center and we also have its radius. Now it says a line through XY intersects C3 at Z and W, and let the common tangent of C1 and C3 be a tangent to parabola x square equals 8 alpha y. Now it also says these two circles, they intersect at capital X and capital Y. So this is your X and this point, it is your Y. Now basically this XY, it is common chord of C1 and C2, and we know that common chord is given by radical axis, which is S1 minus S2. So this equation will be x square minus x minus 3 square plus y square minus y minus 4 square, and that will be 9 minus 16. Now here x square will cancel, we'll get this as 6x minus 9 plus 8y minus 16, and this is minus 7. Equation of xy, it is given by 6x plus 8y. Now this is minus 9 plus 7 minus 2, so there will be minus 18, 0, and we can divide everything with 2. So this equation will be 3x plus 4y minus 9 equals 0. So this line xy, its equation is 3x plus 4y minus 9 equals to 0, and it's going to intersect this third circle at Z and W. Now for this circle C3, we can find this AC3, which is perpendicular distance of this line from center of the circle. So this AC3 will be 3 into, and this center is at 9/5 plus 4 into 12/5 minus 9 upon under root of a square plus b square, which is 5. Now this is 27 plus 48 minus 45. So there will be 30 by 25, which is simply 6/5. So length of AC is 6/5. And once we have this AC3, we can find length of AZ, because this radius is 6 units. So this AZ will be under root of 36 minus 36 upon 25. So there will be 6 root 24 upon 5, and ZW is 2 times of AZ. So ZW will be 24 root 6/5. Now we also have to find XY. Now for XY, we will find this distance OA, and we know that OA, it will be 0 plus 0, 9. So this is 9/5, and this XY will be 2 times under root of this 9 minus 81/25. So this is 225 minus 81, 144. So there will be 24 upon 5. Now we can start solving these questions. Now first is the value of 2h plus k. Now h and k, they are center of the C3. So basically h is 9/5 and k is 12/5. So 2h plus k is 18 plus 12, 30. 30/5 is 6. So 2h plus k is 6. So this first, it matches with P. Now second one is length of ZW upon length of XY. Now length of ZW is 24 root 6 by 5 and length of XY is 24 by 5. So this is equal to root 6. So that means this second, it matches with Q. Now third one is area of triangle MZN. Area of triangle MZN. This triangle will be 1 by 2 base into height. So this area, it will be 1 by 2. Now base here is MN and MN is 12 into AZ. AZ is half of ZW and that will be 12 root 6 by 5 divided by area of triangle ZMW. Area of triangle ZMW, this triangle, and here this is your base and that's your height. So this area will be this 1 by 2. Base is ZW, which is 24 root 6 by 5 into this AM. Now OA is 9 by 5 and this is 3. So it will be this 9 by 5 plus 3. 15 plus 9 is 24. So it will be this 24 by 5. Now this is 12 root 6 by 5. It will cancel. Now this is 2. So this value is 5 by 4. So this third, it matches with R. Now fourth one, we have to find alpha, and it says a line through XY intersects C3. Let a common tangent of C1 and C3 be tangent to this parabola. Now this is C3 and this is C1. So their common tangent will be this line. Now these C3 and C1, they touch each other internally. So they'll have only one common tangent. Now for this, what we'll do is we'll first find the coordinate of M. Now basically origin is midpoint of M and C3. So basically coordinate of this point M will be simply minus 9 by 5 and minus 12 by 5. And we can also find slope of this line. Now slope of this line is 4 by 3. Then slope of this other line will be minus 3 by 4. So equation of this common tangent will be y plus 12 by 5 and will be equal to minus 3 by 4 into x plus 9 by 5. Now this is 4 into 5y plus 12 and that will be equal to minus 3 into 5x plus 9. So its equation will be given by 15x plus 20y. Now this is 48 plus 27 plus 75 equals 0, or 3x plus 4y plus 15 equals 0. Now this line, it is tangent to this parabola x square equals 8 alpha y. Now for this parabola, equation of tangent is given by y equals mx minus am square, and a in this case is 2 alpha. So it will be 2 alpha m square. So if we express this equation, then it will be this y equals minus 3 by 4x minus 15 by 4. So if we equate the two equations, we get minus 2 alpha and m square is 9 by 16 and it will be equal to minus 15 by 4. Now this minus will cancel. Now this is 4, this is 2, and this is 2, and this is 5. So we get 3 alpha is 10, or value of alpha is 10 by 3. So basically this fourth will match with U. Now which of the following is the only correct combination? Second T, 1 U, second Q. So this is your option D. And which of the following is the only incorrect? Fourth S. So this A. 3R, 4U, and 1P. So the correct options are B and A. Now here the question is, let O be center of the circle where R is greater than under root 5 by 2. Suppose PQ is a chord of the circle and equation of line passing through P and Q is 2x plus y equals 5. If the center of circumcircle of triangle OPQ lies on this line x plus 2y equals 4, then the value of R is. So we have this circle with center at origin and radius equals R. And chord of the circle is PQ, whose equation is 2x plus 4y equals 5. And as we can see, its perpendicular distance is 5 upon root 20, which is 2 root 5. So this distance, it is less than R, and therefore they have given R should be greater than under root 5 by 2. Now it says, if circumcircle of triangle OPQ lies on x plus 2y plus 4 equals 0. So circumcircle of this triangle OPQ. So we have this circumcircle of triangle OPQ, and it lies on this line which is parallel to this given line. So it will lie on this line which is x plus 2y equals 4. Then we have to find the value of R. Now if we join this center with P and Q, this CP is equal to CQ, and this distance from the origin to this line, it will be 4 by under root 5. So this OC is 4 by under root 5, and basically OC is same as CP and CQ. So it is also equal to CP and CQ. Now suppose this point is A. Now OA is 5 upon 2 root 5. So we can find the CA. CA will be 4 root 5 minus 5 upon 2 root 5, and that will be basically 3 upon 2 root 5. Now what we are trying to do is, we are trying to create AP square from these two right angle triangles. So we can write AP square as CP square minus AC square, and will also be equal to OP square minus OA square. Now CP is 4 by root 5, so there will be 16 by 5 minus AC square, and AC is 3 by 2 root 5, so there will be 9 by 4 into 5, and OP square is R square minus OA square is 25 by 20. Now this is plus 16 by 20, and which is 4 by 5, and this is equal to R square. Now R square is simply 4, so value of R is 2, and that is the answer to this question. Now here the question is, let W1 and W2 denote the circles x square plus y square plus 10x minus 24y minus 87. So that's your W1, and then the second circle, which is W2. That says, let M be the smallest possible value of A, for which this line y equals ax, it contains the center of the circle that is externally tangent to W2 and internally tangent to W1. So basically we are talking about a circle which touches W1 internally and W2 externally, and whose center lie on this line y equals ax, and the smallest possible value of A is given as m. Now it says if m square is p upon q, then find the value of p plus q. Now for W1, center is at minus 5, 12 and its radius will be 25 plus 144 plus 87, and there will be 6, 256, which is 16. So center one is minus 5, 12 and radius is 16. And for this second circle, center is at 5, 12 and its radius will be 25 plus 144 minus 153. So there will be 169 minus 153, which is simply 4. And if we look at C1, C2, C1, C2 is simply 10. Now suppose center of this required circle is H, AH and its radius is R. Now W1 and W, they touch each other internally. That means distance between the centers, which is under root of H plus 5 whole square plus AH minus 12 whole square, will be equal to R1 minus R2. So it will be 16 minus R. Now W2 and W, they are externally tangent. That means C1, C2 equals R1 plus R2. Now in this case, it will be this under root of H minus 5 whole square plus AH minus 12 whole square, and they'll be equal to 4 plus R. Now we'll add them. So this R will get eliminated. So now we can write this as under root of H plus 5 plus AH minus 12 whole square plus under root of H minus 5 plus AH minus 12 whole square, and they'll be equal to 20. Now this is center of the circle C1 and this is center of the circle C2, and this center is C. Now if you look at this equation, then this is CC1 plus CC2, it is equal to 20. So that means this point C will lie on an ellipse whose foci are at plus minus 5, 12, and this is equal to 2a, and we'll use capital A. So 2a equals 20, and distance between centers, which is 10, it is 2ae. So 2ae is 10. So from here we'll get the value of e as 1 by 2 and value of a as 10. And b square is a square into 1 minus e square, and that will be 100, 1 minus 1 by 4, and that should be 75. So we have this ellipse with focus at minus 5, 12 and plus 5, 12. So its center will be at 0, 12. So it will be this ellipse whose equation is x square upon 100 plus y minus 12 whole square upon 75, and it is equal to 1. Now we have to find a point on this ellipse so that line joining the point to origin has the least slope. So we'll have to find this point where this line will be tangent to this ellipse. So we have to find this slope. Now we can write equation of tangent to this ellipse. So it will be y minus 12 mx plus minus under root of a square m square. So there will be 100 m square plus 75, and we want this tangent which passes through 0, 0. So we'll put x is 0 and y is 0. So there will be minus 12 equals plus minus under root of 100 m square plus 75. Now we square it, we can write 144 equals 100 m square plus 75, or 100 m square equals 69. So value of m square is 69 by 100. So we'll get the least value of a, which is m, such that m square is 69 by 100. Now it says this m square is p by q. We have to find the value of p plus q. In this case, value of p plus q, it is 169. So answer to this question is value of p plus q is 169. Now here the question is, let T1 and T2 be two tangents drawn from -2, 0 onto the circle x square plus y square equals 1. So we have coordinate axis, and then we have this circle x square plus y square equals 1. And from this point, -2, 0, two tangents are drawn to it. So here, center is at origin and radius is 1 unit. So this is -1, 0, and this is 1, 0. Now it says determine the circles touching C and having T1, T2 as their pair of tangents. So we need to find equation of circles which touch this given circle and also these two lines. So we'll have two such circles, one here and another one which will be drawn like this. And further find equation of all possible common tangents to these circles when taken two at a time. Now we'll draw these perpendiculars. This is 90, this is 90, and this is also 90. Now here, this is 1 and this is 2, and if this angle is theta, we can write sine theta equals 1 by 2, that is theta is pi by 6. Now suppose this point is h, 0 and its radius is r. Then we can write sine theta, which is 1 by 2, will be r upon h plus 2, or h plus 2 equals 2r. So the value of h is 2r minus 2, and that's our first equation. And if you find equation of these two tangents, say t1 equals 0 and t2 equals 0. Now here this angle is pi by 6. So here the slope will be 1 by root 3 and here will be minus 1 by root 3. So this t1 will be y minus 0 1 by root 3 x plus 2, that is x minus root 3y plus 2 equals 0, and this t2 will be y minus 0 minus 1 by root 3 x plus 2, and will be x plus root 3y plus 2 equals 0. Now we need to find another relation between h and r. Now we know that this distance, it is mod h, and it is equal to 1 plus r. So basically we can write plus minus 1 plus r, it is equal to 2r minus 2. If we take this plus sign, we'll get r equals 3, and if we take minus sign, then we get r as 1 by 3. So radius of this smaller circle, it is 1 by 3, and radius of this bigger circle, it is 3. And once we have radius, we can write their centers also. Now in this case, when r is 1 by 3, this is 2 by 3 minus 2. So there will be minus 4 by 3. So center of this circle will be at minus 4 by 3, 0. And for this circle, center will be at Now this is 6 minus 2, 4, 4, 0. Once you have center and radius, we can write equation of both the circles. So equation of this first circle will be x plus 4 by 3 square plus y square equals 1 by 9. And the equation of this larger circle will be x minus 4 whole square plus y square equals 9. So these are the equation of two such circles. Now we have to find equation of all common tangents. Now in between these two circles we have these two lines, and then we'll also have this common tangent. So equation of this common tangent will be, say, T3 and will be given by x equal to minus 1, and here also we'll have this common tangent which is, say, T4 and will be x equal to 1. So that's your circle C. This is suppose C1 and this is your C2. So in between C and C1 we have T1, T2 and T3, and in between C and C2 we'll have T1, T2 and T4. Now in between C1, C2 we'll have two direct tangents which are simply T1 and T2, and we'll also have two transverse tangents which we want to work out. So we have to work out two transverse tangents in the case of C1 and C2. Now we'll redraw it. So we have two circles, C1 and C2, and we are looking for their transverse common tangent. Now this center, it is at minus 4 by 3, 0, and here this is 4, 0. This radius is 1 by 3 and this radius is simply 3. Now we know that this point, we'll divide them in the ratio R1 is to R2, and this ratio is 1 by 3 is to 3, so it will be this 1 by 9. So we can find this point as 4 minus 12 upon 10, 0. So it will be minus 8 by 10 or minus 4 by 5. So this point P, it is minus 4 by 5, 0. Now we have to find equation of pair of tangents to these. Now we know that equation of this line, it can be expressed as y minus 0 equals m x plus 4 by 5, or simply 5mx minus 5y plus 4m equals to 0. Now perpendicular distance from center must be equal to its radius. So we'll get 20m plus 4m upon 5 under root 1 plus m square, and it will be equal to its radius, which is 3. Now this is 24, which is 8m, and if we square it, we'll get 64m square is equal to 25 and 25m square. This is 39m square equals 25. So value of m is plus or minus 5 by under root 39. So equation of indirect common tangents, it will be given by y equals plus minus 5 by under root 39 x plus 4 by 5, and that is the answer to this question. Now here the question is, let T be a line passing through the points PQ, and let F1 be set of all points of circle such that T is tangent to S1 at P and tangent to S2 at Q, and also such that S1 and S2 touch each other at a point, say M. Let even be the set representing the locus of M as the pairs S1 S2 varies in F1. Let the set of all line segments joining a pair of distinct points of E1 and passing through all the points R be F2. Let A2 be set of midpoints of line segments on the set F2, then which of the following statement is or are true? Now we are given this straight line, and we have 2 points on this line, and there are 2 circles which touches the straight line at these points P and Q. So we have 2 points on this line, and there are 2 circles. Now suppose this is your point P, minus 2, 7, and Q is 2, minus 5. This is S1 and this is S2, and this set is F1. Suppose their centers are at C1 and C2. And they touch each other at this point M. So this F1 is set of all circles and E1 is set of locus of M as S1, S2 varies. Let's set of all straight line segment joining pair of distinct points of E1 passing through point 1, 1. Now let us draw this perpendicular line from M. So this is 90. Let's join these 2 lines. Now this is 90 and this is 90. And we have joined P with M and Q with M. Now let this angle be theta. Then this angle here will be theta. Then angle at the center will be 2 theta. And this angle here will be pi minus 2 theta. In the same way, if this is alpha, then here it will be this 2 alpha. This angle will be pi minus 2 alpha. Now sum of these 2 angles, it is pi, so we can write 2 pi minus 2 theta plus alpha, it is equal to pi, or theta plus alpha is equal to pi by 2. That means this angle PMQ, it is always 90 degrees. And if PMQ is always 90 degrees, then locus of M is circle with PQ as diameter. So basically this E1, which is locus of M, it is the circle drawn through PQ as diameter. So this E1 will be given by x plus 2 into x minus 2 plus y minus 7 into y plus 5 equals to 0. So this E1 will be given by x square plus y square minus 2y minus 39 equals 0, except these points P and Q. So this M, it cannot take these 2 points P and Q. So we have to exclude these 2 points except PQ. So this is the locus of this point M. And basically we can write this as x square plus y minus 1 whole square equals 40. Now it says we have this circle and E2 is set of midpoints of this chord. So E2 is set of midpoints of the chord which pass through this point 1, 1. Now let this point be alpha beta. We know that equation of a chord whose midpoint is given, it is given by T equals S1. So in this case, this equation will be given by alpha x plus beta y minus 2 y plus beta upon 2 minus 39, and that will be equal to alpha square plus beta square minus 2 beta minus 39. Now this minus 39 will cancel, and this chord, it passes through 1, 1. So we'll put x as 1 and y as 1. So we'll get alpha plus beta minus 1 minus beta, and that will be equal to alpha square plus beta square minus 2 beta. Now here beta and beta will cancel. So we'll get this locus as alpha square plus beta square minus alpha minus 2 beta plus 1 equals to 0. So locus of E2 will be this circle, which is x square plus y square minus x minus 2y plus 1 equals 0. Now we have to check the 4 options. So now we have the 2 locuses. E1, which is x square plus y minus 1 whole square, and it is equal to 40, except the 2 points P and Q. P, which is minus 2, 7, and Q, which is 2, minus 5. And this other locus, which is E2, and that is x square plus y square minus x minus 2y plus 1 equals 0. And since E2 is midpoint of chord of this circle passing through 1, 1, so it'll have all the points except chords which pass through P and Q. Since P and Q, they are not included on E1, so any chord which starts from P and Q will also not be included in this second locus E2. Now we look at the options. Now the first option is point minus 2, 7 lie on E1. Now minus 2, 7 is basically point P, which is not included on E1. So that means this option A is incorrect. And this option D is the point 0, 3 by 2 does not lie on E1. So we'll put the value of x and y. We'll put x as 0. So it'll be this 0 plus, now 3 by 2 minus 1 is 1 by 2, 1 by 4. It is equal to 40, which is incorrect. That means it is correct that this point 0, 3 by 2, it does not lie on E1. So that means this option D is correct. Now we look at this option B. Now we look at this option B. We are given this point 4 by 5 and 7 by 5, and it says it does not lie on E2. Now we'll put the value of x and y in E2. So we'll get 16 by 25 plus 49 by 25 minus 4 by 5 minus 14 by 5 plus 1. It is equal to 0. Now this is 49 plus 16, 65 by 25, which is 13 by 5 minus 18 by 5 plus 1, which is 0. That means this point, it does lie on E2, but we have this other condition that any chord must not pass through P and Q. So we have to find whether this point 4 by 5, 7 by 5, 1, 1, and then P or Q, they are collinear or non-collinear. So we'll solve this determinant. So what we'll do is we'll take C1 minus C2 and C2 minus C3. Now 4 by 5 minus 7 by 5, it is minus 3 by 5, and 7 by 5 minus 1 is 2 by 5. This is 1. This is 0, 0, 1, and this is minus 9, 6, and 1. Now if we expand it about this second row, we'll get this as minus 18 by 5 and plus 18 by 5, and it is equal to 0. That means these 3 points, 4 by 5, 7 by 5, 1, 1, and P, they are collinear. So this chord will actually pass through P, and since the chord passes through P, this point, it cannot lie on E2. That means this option B is correct. So the point does not lie on E2, though it satisfies its equation. Now this third one is point 1 by 2, 1 lies on E2. So now we'll put the value of x as 1 by 2 and y as 1. So it will be this 1 by 4 plus 1 minus 1 by 2, minus 2 plus 1, so we'll cancel, and this is minus 1 by 4, which is unequal to 0. So this point C, it does not lie on E2. So the only correct options are B and D.